This is the NEET 2016 question in electric charges and fields. The problem says, two identical charged spheres suspended from a common point by two massless strings of length L are initially at a particular distance d, which is much less than L. Apart from their mutual repulsion, the charge begins to leak from both the spheres at a constant rate. As a result, the spheres approach each other with a velocity v. V varies as a function of distance x is. So first let's try to understand what is given for you. There are two spheres. Assume this is the fixed support. To this fixed support, there are two spheres suspended to two strings of length L. Each of the sphere is having a charge q. As the charges are similar between them, there is a repulsion. This is also q. So each one is moving outward because of the repulsive force between them. There is a certain distance of separation between them, but as the charge leaks out of the spheres, that distance, as the charge reduces, force of attraction reduces, then they comes close to each other with a velocity v. We have to find the relation between that velocity and this distance. Let's assume this distance is x. Distance between two of the spheres initially is x before the beginning of the leaking. So if this is the midpoint, this distance becomes automatically x by 2. There is an angle with which it is separated with the vertical, let that angle equal to theta. This is the force of repulsion, and on that small body there is a mass also acting, weight mg. So if I extend this line, this angle also becomes, as that angle is theta, this angle is also theta. So you can see two right angle triangles there. Yeah, let me draw with another color. So this mg will be one side, this f becomes parallel to this, and this is the right angle triangle. So there I can write tan theta is, opposite side is this f by mg, right? Then what is the tan theta here in the other triangle? If you consider there is other triangle, this triangle, here also you are having a theta, same theta. So for that tan theta is, opposite side is x by 2 by this adjacent side. As this is L and this is x by 2, this becomes root of L square minus x by 2 whole square, x square by 4. So this becomes root of L square by x square by 4, where F is the force of repulsion between this sphere and this sphere. I can write using a Coulomb's inverse square law, 1 by 4 pi epsilon naught, a constant k otherwise, q1 q2 by mg is tan theta. On the other side, tan theta is x by 2 by root of L square minus x square by 4. So what we can say is, sorry, there is one more thing I have missed. 1 by 4, force of repulsion is 1 by 4 pi epsilon naught q1 q2 by separation square. Separation is x. So by x square is also there. So taking all the other terms as constants, from here you can write q square is directly proportional to x cube. So thus we found q square is directly proportional to x cube because there is an x square and there is another x. This x square, when go to the other side, directly becomes x cube. From that we can further say q is directly proportional to x power of 3 by 2, right? Now let us differentiate this q because this q is being leaked with respect to time. So I can write dq by dt is, all proportionate constants, differentiation becomes 0. So I need not write that. What I can write is dx power 3 by 2 by dx and dx by dt. See, what I have done is, if you have noticed, there is dt here, so I have written dt, but I am differentiating with respect to x, that's why I have multiplied with x and divided with x, so that it is compensated, and we will be able to differentiate after this with respect to x. So what we can say further is, rate of leak of charge dq by dt is d by dx of x power 3 by 2. dx by dt is rate of change of displacement, that's nothing but velocity, right? So dq by dt is, by differentiating this, differentiation of x power n, we have a formula, n into x power n minus 1. So differentiation of x power 3 by 2 means, in the place of n you have 3 by 2 x power 3 by 2 minus 1 multiplied by v is dq by dt. I don't write equate, I will write proportionate, because we only got a proportionality all these places. So what I can write is, dq by dt is proportional to x power of 3 by 2 minus 1 is 1 by 2 and v. So if I have to get the v and x to the other sides, v is directly proportional to x power minus 1 by 2. So v is directly proportional to x power minus 1 by 2 is the answer for the problem. I have not taken all the other constants into equation because that is not necessary as of now, because we only need a proportionality relation. I found that relation. So it's a very simple thing to solve this problem. Only thing that you need to know is, how do you write a tan theta in the given two triangles. This is one triangle and this is the another triangle. Once if you understand theta is same for both of them, and if you are able to equate that, then you will be getting your answer quite easily. That's it. Thank you for watching.